Hey everyone, so today we will start going over what it means to be an even function or an odd function. You should have hopefully got a blue note sheet that looks like this on one side and then notes on the inside. If you need an example of how to fold this up, I did stick one to the front whiteboard with a magnet so you could just take a look. Okay, but even functions, so that would be the left side of this foldable. We're going to talk about how you can identify it from the graph and how you can identify it algebraically. So when you are looking at a graph, you'll know that it's even because the graph has reflectional symmetry over the y-axis. So I have two graphs underneath, and it says determine whether each function graph below is an even function. So again, reflectional symmetry over the y-axis. So taking a look at my y-axis, let me use my highlighter here. Here's my y-axis. Does it look like a reflection across that line? So basically, is it exactly the same on the left and on the right? So if you look closely, yes it is. So this is an even function. Okay, let's take a look at the other one. So kind of the same shape where it has like those bumps. And it definitely looks like I can fold it in half and it'll be the same on both sides. The problem here is that this time I would have to fold it right here down the middle, and then it would be even on both sides. The problem is, in order to be considered an even function, you have to be able to fold it on the y-axis. So see how those are not the same line? So that means that this is not an even function. Because it reflects over the wrong line. So reflects over the line x equals 1. And that is not the same as the y-axis. So honestly, it's just as easy as that when you're looking at a graph. Is it reflection over the y-axis? Algebraically, it's a little bit tougher. So the rule is a function is even, so even, if this is true. F of negative x is equal to f of x. So whether I plug in a negative 5 and a positive 5, those two x's are going to give me the same y value. If I plug in negative 3 and positive 3, again, if I plug them both in, I should get the same number both times. So I have two examples here of equations. Let's take a look at example 3. Okay, so let us say that x is 2, which means that negative x would equal negative 2. So see how they're the same number, just one's positive, one's negative. So let's first plug in that positive number. So when I say plug in, we're just going to replace our x value with the number given. So f of 2, let's plug that in. Okay, and if you do this simple math, or if you want to, you can honestly do this in your head, but I'm going to show all my steps. So the 3 is going to be there, but I know that 2 squared is 4. So I put a dot in between because I know I need to multiply, and then I'm going to need to add that 8. So now if I do this, 3 times 4 is 12, plus 8 is 20. Okay, so now I want to try putting in negative x. So this time I want to put in negative 2. So same deal, 3, but plug in negative 2 this time. And now let's see what this equals. So this 3 times, well, what is negative 2 to the second power? So it turns out that is also positive 4, because negative 2 times negative 2. So fill out the rest. 3 times 4 is 12, plus 8 is 20. So what I want you guys to notice here is that they both equal the same number. So what happened is that f of negative 2 is equal to f of positive 2. See? So since they are equal, yes, this is an even function. Okay, so let's do another example. Let's do the one right next to it. It's the same deal. This time I have f of x equals 2x squared minus 12x plus 7. You can use any number you want. I tend to use small numbers because I want to do the least amount of work as possible. So this time, let's say that I'm going to just keep using the 2. So let's say x equals 2, which means that negative x would equal negative 2. Oops, extra dot. Let me erase that. Okay. So I'm going to start with a positive one. So f of 2 would equal. Now I'm going to plug in that 2 anytime I see an x. So in this case, I have it there twice. So 2, but plug in our 2 squared, minus 12, plug in our 2, plus 7. Okay, so I'm going to try to simplify as I go. So I know that 2 to the second power is 4. 12 times 2 is 24. And then I still have my plus 7. 2 times 4 is 8. Okay, so if I have that all together, 8 minus 24 is negative 16. But then plus 7 is going to be negative 9. Okay, so now I want to try plugging in a negative 2. So same equation as above, just what's inside the parentheses is going to be negative. So we're going to start off pretty similar. Negative 2 to the second power is positive 4. But now I have 12 times negative 2. That's going to give me negative 24. Then plus 7. So I have a few things to fix. I know 2 times 4 is 8. But then this part right here, minus a negative number is going to turn to a plus sign. And then I still have my plus 7. So if I add all of those up, I get 39. Okay, so in this case, the two numbers are not the same. So negative 9 is not the same as positive 39. So here I would say f of 2 is not equal, so equal sign with a slash, to f of negative 2. And since they are not equal, this is not an even function. Okay, so that's pretty much the basics of even. On a graph, has to be the same on both sides of the y-axis. Algebraically, if I were to plug in a negative number and a positive number, you should get the same output. Okay, so now let's look at what it means to be an odd function. So this is going to be the right side of the foldable. So an odd function is a graph that has rotational symmetry around the origin. So this time you can't just fold it in half and have it be the same. You have to be able to spin it around. Okay, so I have two graphs here, and we're going to determine whether each one is an odd function. Okay, so here's the first one. This looks like a cubic function, so x to the third power. But is it odd? So the one rule that we have is that it has to rotate around the origin. So if this is my origin, and I try to rotate this, it would turn into something like, let's see how close I can get this. Something like that. So it's not rotational. So think about it if I went kind of clockwise like this. It is not rotational around the origin. it is rotational. I'm going to erase my markings. So it is rotational around here. If you were to put your finger on that point and spin it, yes, it would be the same, but it has to be around the origin. So in this case, not an odd function. Okay, so what about the one next to it? So I'm sure you guys can guess. So this time, sure enough, it's going through the origin. Now think, if I were to get this piece and kind of just spin it around, it would land exactly on this piece here. And then if I were to take this piece and spin that around, it would land exactly here. So basically, if I were to spin this around the origin exactly 180 degrees, it would look exactly the same. So this, yes, is an odd function. Okay, so now I want to take a look at what it means to be odd algebraically. So what we're going to look for is f of negative x is equal to negative f of x. So don't get too confused. It almost looks like with even. Only difference is that with odd, there has to be that negative sign out front. And I'll show you what I mean here. So we're going to pick a value, any number. You can pick 2, 3, 4, 5. I like to pick 2 because it's small enough to be easy to calculate, but big enough to actually see some progress. So let's say that x is 2. That would mean that negative x is negative 2. So if I look at here, I'm going to start by plugging in the negative number. Okay, so anytime I see an x, I'm going to replace it with a negative 2. That looks like a z. Let me fix that. Okay. I want to calculate how much this exactly is. So we're going to start with our exponents. So since that is to the third power, that means that I need to get negative 2, and I need to multiply it 3 times. And then that second part kind of stays the same. So now it's a little bit easier for me to actually look at what I'm doing. So I'm going to go in order here. Negative 3 times negative 2 is positive 6. Times the negative 2 is now negative 12. But times negative 2 again is now a positive 24. Then plus 2 times negative 2 is negative 4. So I know it looks kind of weird, but this is pretty easy to solve. 24 plus negative 4 is 20. Okay, so now I'm going to look at what happens if I plug in positive 2. Okay, so we already know that exponent means that I need to have 2 there 3 times. So this makes it a little bit easier for me to calculate. Negative 3 times 2 is negative 6. Times 2 again is negative 12. Times 2 again is going to be negative 24. And then plus 2 times 2 is 4. So negative 24 plus 4 gives me negative 20. So something interesting happened this time. So yes, it's the same number. They're both 20, but one is positive and one is negative. So what does that mean for us? So I'm going to go back to my algebraic rule. It says f of negative x should be equal to negative f of x. So that means if I plug in the negative number and I get a certain number, when I plug in the positive value, I'm going to get that same number with a negative sign. Isn't that exactly what happened here? So positive 20, negative 20. So this is an odd function. So yes, an odd function. Okay, and then let's look at our last one. So here's our new function here. And then you can easily identify, those are my x's, so I'm going to plug into there. And I'm just going to continue using 2. It's easy. So if x is 2, negative x is negative 2. So let's start by plugging in the negative 2. Okay, so negative 2 to the third power is like saying negative 2 times negative 2 times negative 2 minus negative 2 to the second power is like negative 2 times negative 2, and then I'm still going to have that 1. So to me, this makes it easier for me to see. So now if I have negative 2 times negative 2 times negative 2, that gives me negative 8 minus, and now over here, negative 2 times negative 2 is positive 4, and then I still have that minus 1. So altogether, we have negative 13. Okay, so for this to be an odd function, when I plug in the positive number, I want to see a positive 13. So let's see if that happens. So if I plug in positive 2, so this would be 2 cubed minus 2 squared minus 1. So I kind of know from before, 2 cubed is 8 minus 2 to the second power is 4. And I still have minus 1. So this gives me positive 3. So 2 totally different numbers. We were hoping for like a positive and a negative of the same value. This time it's completely different. So this means that this is not an odd function. Okay, and that's everything about the odds. So for odd, it has to rotate around the origin. That's a really big part of a graph. And when you do it algebraically, let me erase so we can see it better. If I plug in a negative value and I plug in a positive value, their outputs will be the same number, but a positive and a negative one. Okay, so I know I kind of went through that in a hurry. So hopefully we got everything written down. I will post this video so you could always pause, rewind, fast forward if you need to. Make sure that you fill out the notes, you fold it, and you glue it down in your notebook. And I will see you guys tomorrow.